In this video we're going to use double integration with polar coordinates to work out the area of this region. So the idea is that we're going to scan through like this. So we're going to scan through like this. Hang on. We're going to scan through like this. So we are going to scan. Let's look at this one here. We start at the vertical line, so we're going to scan like this. We start at the vertical line and then we stop at the circle. We start at the vertical line and then we stop at the circle. We start at the vertical line and then we stop at the circle. So the idea is that we're going to cover, eventually we're going to cover the whole region. So eventually we're going to cover the whole region. We're going to cover the whole region. So set up our area is given by the double integral. Remember, this is dr, so it's going to be r equals something and r equals something, and then looking at the outer integral is going to be theta equals something, theta equals something. So the idea is r starts at the vertical line and then it stops at a radius of 2. So it starts at the vertical line and it stops at 2. It starts at the vertical line and it stops at 2. It starts at the vertical line and then it stops at 2. We need to figure out the radius for this vertical line here. Okay, and then in terms of the angle, we're scanning from this angle here, negative whatever this angle is, and then we stop at whatever this angle is. So hang on, we're going to start at this angle and then we stop at this angle here. So we're scanning through this whole angle here. We're scanning through this whole angle. So it's going to be r equals something, r equals something, and then theta equals something, theta equals something. We need to work out the vertical line. So hang on. So we need to work out the radius for for any given angle. We need to work out this radius here, because you enter this vertical line, you leave the circle. You enter the vertical line and then you leave the circle. So for any given angle, theta, we have to somehow know the radius of this. So we need to know this r here. So let's look at this triangle here. Hang on. Let's look at this triangle here. So let's look at this triangle. For any given theta, we need to know the radius, and this length is always 1. It's always 1. So we need to work out the radius. So this is going to be cos the angle equals 1 over r. 1 over r. So we need to know r. We need to know the radius for any given angle. So r will be r equals 1 over cos theta, which is the same as secant theta. So really we are integrating from the radius of secant theta to a radius of 2, because look, you enter, this radius here is, so this angle is theta, this radius will be secant theta, so that's our radius. So you start at the radius, you start at the vertical line and then you leave at a radius of 2, So let's say your angle is, hang on, let's say you've got a bigger angle now. So you start, so for this given angle here, theta, this radius here is secant theta. So you start at secant theta and then you leave at a radius of 2. So you leave at a radius of 2. So really r starts at secant theta, stops at r equals 2. And we are scanning in terms of the angle theta. We are scanning from this angle here, which will be negative whatever. We've got to establish this angle, and then we stop at this angle here. So we need to work out this angle. Okay, so hang on. So we know, looking at this triangle here, looking at this triangle, we know that, so looking at that triangle, we know that it has a length of 1. We need to know the height. Well, this circle has a radius of 2. So equation of a circle of radius 2 would be this. So well, we know x is 1. We want to work out the height, so we put 1 into the x. So that would then give us 1 plus y squared equals 4. So y would be, take away 1, so y would be root 3. So this height here is root 3. So so from this, I hope you recognize that this is a famous triangle. If you consider an equilateral triangle where this is 2, this is 2, when you cut it down the middle, this will be 1. Using Pythagoras, we can work out the height as being root 3. So whenever you see root 3 and 1, this length here must be 2. It's a famous triangle. You should recognize this triangle. Well, anyway, this is 60 degrees, known as pi over 3. This is 30 degrees. We don't care. Well, if so we are really integrating from an angle of negative. So an angle of negative, from an angle of negative pi over 3 to an angle of positive pi over 3. So we're scanning through like this from an angle of, we're scanning like this from an angle of negative pi over 3 to positive pi over 3. So our final setup for our double integration is given by this. Is given by this. So we enter the radius of this. We leave a radius of 2. We're scanning from an angle of this to an angle of this. So the whole area is given by us trying to evaluate this. So now, looking at the inner integral, we need to integrate r with respect to r. So integrating this would be this, from a radius of secant theta to a radius of 2, to a radius of 2. So that will then take us to here, and then we would put this into here. So this whole thing here would be 2, and then take away, and then put this into here. So that would give us secant squared over 2. That would then give us this. So now let's factor out the half. So so factor out this half here. So this will become a 4, and then from here that will then take us to here. So now integrate this. Hang on. So now now integrate this. Integrating the 4 with respect to theta gives you 4 theta. Integrating this will give you tan theta. Now we've got to put this into here. That will then give us this. Take away. This is your takeaway here, and then put this into here. That will then give us this, and then take away, and now put this into here. That will then give us this, and then put this into here. That will then give us this. So now it's a matter of tidying this up. So hang on. So so tan this block here, tan 60 degrees. Well, if you look at this, this is 60 degrees, this is pi over 3. So tan, you can see tan is root 3 over 1. So tan, this block here is basically root 3 over 1, which is root 3. And this thing here, using the same argument, that if you look at this triangle, this is negative pi over 3. Well, this is going to be negative 3. Well, this block here will become negative root 3. Well, if you think about it, don't forget you've got a negative here, and then you've got a negative here. Well, think about it. It should take you to this whole thing here. So now now merging these two together will then give us this, and then this will be 2 root 3, but I want the denominator of 3, so that would be 6. So this thing here will then give us this. So it's blah blah blah, and the final answer is given by this. So that area is given by this. Okay.